Hi everyone, today I'm going to talk about Newton's law. Before Newton, people believed Aristotle, which is a philosopher, and now he's a statue, so Aristotle says that anything stays at rest. You require force to keep the things moving, and then Galileo Galilei, which is people right here. So he did an experiment. There's two ramps. He found when he rolled a ball down, the roll will go up and at the same height. And even he put it at different angles, it still got to the same height. So he believed that if this ramp is flat, the ball will just go forever because they can't get to the same height. So Newton's first law of motion. So what did Newton say? So Newton's first law is about inertia. Object at rest will stay at rest unless you add some force on it. And an object in motion will continue at motion at the same velocity, or you can say the speed and direction. So true or false about Newton's law? First, if the net force on a body is zero, the velocity will not change. So it's correct. If the net force is zero, but you can see if there's a rock right here, and there's only some grass right here, this force acts on that. So one is the gravity, one is normal force. But it's in opposite direction, so they cancel each other out. So the net force is equal to zero. And unbalanced force on a body will always impact its speed, but it's not correct. Why? So, like when you are doing something, you travel in circles. The speed is set, but the direction is always changing. So, it's not just speed, sometimes direction. So, you can say the velocity is changing because the velocity is a vector quantity. A stationary object has no force act on it. So I talked in the first question already that there's normal force and gravity. Newton's second law. So what did Newton's second law say? He said that acceleration, so he said F is equal to ma. So F is equal to ma. So F is the force, and the m is the mass, the a is the acceleration. So some people said French fries is equal to mashed potato times olive oil. So it's not correct, Acceleration and the force is proportional to the force, but the mass and the acceleration is inversely proportional to each other, So if there are multiple force, you have the vector sum of force, so which is called net force. And I talked in the net force is a different direction, need to cancel the weight and normal force, right? So when the net force equals zero, like this pen is not moving, it is called translation equivalent. Newton's second law. So when the force is applied on an object, it is not always moving, remember? So why? So, like when you are, maybe there's some clay, and you just press the clay, you're acting a lot of force, but the clay is not moving, it's just changing its shape. Mass and weight. What difference between mass and weight? So mass and weight is totally different. Even the number is same on Earth, So, mass is a measure of the amount of matter on an object. Like the mass of you on Earth is same as the mass of you on your moon. Like maybe you are 10 kilograms, maybe, maybe you are 10 kilograms, and you put the 10 kilograms. So like you are 10 kilograms, you sit down here, and there's a stone with 10 kilograms of mass. And now you change this. Now it's on the moon, okay? And then it's still balanced, but weight is always different. Like now you are 10 kilograms. No, maybe you are 6 kilograms, and now when you are on the moon, you're only 1 kilograms. So it's different. So weight is the measured amount of gravity between you and the Earth, Moon, or other planets or stars, okay? So Newton's first law. What is Newton's third law? So Newton's third law is, what is it say? Let's say, have you hit someone before? So if you hit someone, sometimes your hand turns, this your hand, and you found it become red, 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 and then you found your hand is red, 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 red. Right, why? So whenever you hit anything, like you hit this, it gives you a certain amount of force to you, okay? So, but it's on different things, like this is on the screen, but another force is on my hand, okay? So it's on different direction and different objects, okay? So it's different from the normal force and weight. So why? So because when people stand right here, okay, the normal force is down, but the weight is, the gravity is down, and normal force is up. But they cancel each other out because it's on the same object. So this is not equal to you can know normal force and weight. It's different. This is on practice now. Okay. 500 newtons of right toward the net force is accelerating object, right? 5 meters per second squared. What is the mass of the object? So now F is equal to ma. So F is equal to 500, you tell, and it's equal to mass times acceleration. So 5m. So m is equal to 100. So y is kilograms. So because Newton is equal to mass kg per second squared, then you just divide it by mass per second squared, so you get kilograms. That's why. Okay. You applied 8 newtons of horizontal force on a 4 kilograms of stationary object and ignore the friction in air resistance. What is acceleration? What is acceleration? F is equal to ma. Okay, again, 8 is equal to 4a. A is equal to 2. So now a is equal to 2, so the acceleration is equal to 2. What is the velocity and displacement on a 5 seconds? So we need to use the kinetic equation. V is equal to, okay, so the first, V is equal to VO plus AT, okay? So the first one. So because the initial velocity is equal to 0, so we don't need to calculate it. Just V is equal to AT. So V is equal to acceleration with 2 times the time is 5 seconds. So it's equal to 10. So it's 10 meters per second. And what is the displacement? So S is equal to VLT plus 1/2 AT squared. Yes, okay. So this is equal to 0 because 0 times anything is equal to 0. So S is equal to 1/2 AT squared. So T is 5. 5 times 5 is 25 times 1 because 2 divided by 2 is equal to 1. So the answer is just 25. If you add 12 newtons force on a 5 kilograms of object and makes 2 meters per second squared of acceleration, how many force objects get at the same time on you? Okay, at the same time. So first, if there's an object, so first what does it get? First, it gets normal force because it's got the normal force upward. So how much is the normal force? So it's equal to the weight. 5 kilograms. But if we change it into newtons, it's 5 times 9.8 is equal to 49 newtons. Okay, it's normal force, but there's also frictions. So now we can see. Okay, now we can see 12 newtons. So F is equal to ma. So it seems like you only add 2 times 5, right? No, 5 times 2 is 10. But you add 12 because 2 of them is frictions. So there are also frictions, 2 newtons of frictions, or you can say it's air resistance or some wind or other things. So now, if you put 5 kgW of force downward and like this, and it's a pulley, and then you put 5 kilograms of object right here. So what is acceleration? So it's totally different. So why? Oh, so what? Wait a second. What is happening? Okay. Okay. So why? So now you can see. So the object is this one. The second one is 5 kilograms. 5 kilograms. It's like this. So the whole thing is 10 kilograms. So you use 5 kilograms of force acts on a 10 kilograms of things. But this one is used 5 kilograms of force acts on a 5 kilograms of things. F is equal to ma. So first we change it into newtons. 5 times 9.8 is the first one, okay? And then we divide it by 5, okay? And then we get 9.8 as the acceleration. And then this one is 5 times 9.8 divided by 10. So it is 2 right here. So 9.8 divided by 2 is equal to 4.9. So the acceleration is totally different. Okay. Now, when you just move 2 things, so the smaller m, capitalized m, is equal to 1 kilograms, and the bigger m, capitalized m, is equal to 4 kilograms. So you can see what is acceleration. So let's see, 10 is equal to 4 plus 1 is the whole acceleration. 10 plus 1 times acceleration. So 4 plus 1 is equal to 5. 10 divided by 5 is times 2. So acceleration will be 2. But the whole thing, if you just do it, is 8 plus 2. If you just times it. So the 8 is a bigger one. The massive is the force you need to push it, and 2 of the acceleration 2. And the 2 is the force you need to push down the smaller mass to keep the acceleration at 2. So first you can see the first one. So if you push it, 8 of the force is acting on the bigger one, but 2 of them is acting on the smaller one. So the force between them is 2. Why? Because the force between them, this force, is the massive to push the smaller ones. So the massive needs to use 2 newtons to push the smaller ones. That's why. Another. This is 2 newtons is on the smaller one, but force 8 newton is the smaller one to push the bigger ones. So the force between them is 8. So it's different. So another type of thing. So now if we put on the top of it, so what will happen? So not counting the friction and air resistance. According to the Newton's first law, something is not moving will keep not moving. So if the bigger mass just goes, and then the smaller one will just fall down. So it's not right, okay? So because we did the same, not counting the friction between them. Okay, so now, wait a second. Okay, let's see. So it's same, all things is same. So you use 8 Newton to push the, and 2 Newton to push the smaller one. Okay, so it's the 8 pulls the smaller ones because you act on the 8. So the between them is 2. But it's different because the 2 is frictions. The massive use of frictions to pull it, so we can know the friction between them is 2 newtons. There's 2 students, okay? If there's 2 students, one is 18, one is 16 kilograms. Push each other on the ice rink. What is the acceleration? So student A, which is the 18, is 3 meters per second squared. What is the acceleration B? So we know if I give that force, it will give the same force to me, right? So the force between them is same. So the force to A is equal to force to B, student. So let's see, 18 times 3, because the m times acceleration A is equal to 16 times an unknown number, or you can say it's x. So then we can find 214 is equal to 16x. X is equal to 4. And then it's done. An inclined line. If the phase weight is 100 newtons, okay, on a 30-degree inclined plane, what is a normal force and what is the force downward the ramp? So this is because we can see this two is parallel lines. So anything get through a parallel line, this is equal to this one. So since this one is same, then so we can know this is equal to 16 because it's 13, 19, so it's 16. Since this is equal to 16, this is equal to 19, so this is equal to 13. So now we can see the sine, cosine, and tangent. So now we can see this, I use a different color, it's better. So now we can know this is 13, so I think I changed the colors. Okay, so this is 2, this is 1, this is the square root of 3. So since we know this 2 is equal to 100 newtons, so 10 is equal to 100, 100 is equal to 10, 2, okay? Then first we know the normal force equal to x over square root of 3. So 100 square root of 3 is equal to 2x. X is equal to 15 times the square root of 3. That's the normal force. And now as force downward is how much? So we're going to calculate this one. So this tells us 1. So just divide it by 2 is equal to 15. Static friction and kinetic friction. What's the difference between static friction and kinetic friction? So static friction is you are moving something, but the thing is not really moving because of frictions. But the maximum friction is friction that you need to, no, it's just static friction, Oh, it's kinetic friction. So and if you're bigger than kinetic friction, it will move. Okay, the maximum static friction. So kinetic friction. What is kinetic friction? Kinetic friction is that it's already moving. The friction between them. So let's two equations. Fs is equal to Fm times Mus. What is this? So the Fs is the static friction is equal to the normal force times and coefficient. And kinetic friction is equal to the normal force times and coefficient. Okay? So let's see some questions. 20 kilograms of objects is put on the table. The coefficient of static friction is this, and is this. What is the force you need to start the move. So start is a static friction. So 20 times 0.5 is equal to 10. So it's equal to 10 kilograms. So 10 times 9.8 is equal to 98. Okay, so it's 98 newtons. You want to hang some frame on a wall, and the frame is 2 kilograms, and the mu is 0.5. How many normal force should you put on the frame to keep it from dropping? So first, like this is a wall, and this is a frame. Okay. So the normal force times so 2 is equal to the normal force. You can say normal force. You can say normal force is x times the 0.5. 5. So 0.5 moved to here. So it's equal to 2 times 2 is equal to 4. It's done.